Alkenes and alkynes occur when the hydrocarbon chain is not saturated. That means it does not have the maximum number of hydrogens. Remember, saturated kind of means full of. So if it's not full of all the hydrogens it could hold, then it is called unsaturated. And this is the same way the terminology works when you talk about saturated and unsaturated fats, because those are organic molecules. The fact that they don't have as many hydrogens as possible in the carbon chains doesn't mean that there's branches, though there can be branches. By saying it's unsaturated, we mean there are double and triple bonds in the hydrocarbon chain. So let's look at alkenes first, and alkenes have double bonds. Remember, when it is a saturated chain with only single bonds, the shape is that little zigzag. However, when there's a double bond or a triple bond present, the bond angles change and become more like this. Now the single bonds are still going to have that zigzaggy look. We don't have to show the hydrogens, so we know that this has 3, and this has 2, and this has 3. But I want to focus on this right here for a second. So because this has 1, 2, 3, 4, 5 carbons in a chain, this is pentane. But the problem is, this right here, we have said the shape hasn't mattered quite so much how we draw it, but that compound and this compound have different properties. Not hugely different, but they are enough different that we need to tell about it in the name. Now, sometimes I will not give you the information in order to tell me about it. If I don't draw it out for you in a structure like this, then you can't tell me about it. But if I do, you need to be able to tell me one thing. If the carbons coming off of the double bond, the next ones out, are on opposite sides, we call that trans. If they are on the same sides, we call that cis. So we would name this one. We have to tell which carbon in the chain the double bond is on, and we want to have the lowest possible. So we would name this trans 2-pentene. And you don't have to tell me about a substituted group because there aren't any. This 2 is telling us where that double bond is. And you can indicate that you're talking about a double bond because it says pentene. And this one would be called cis 2-pentene. And like I said, I'm not always going to give you enough information so that you could tell me cis or trans, but if I draw the shape out for you like that, I do need you to tell me. Let's look at another one like this. So this is kind of a cross between our condensed and our more expanded ways of showing this. So first you should count your carbons, and then you can see no matter which way you count from, the double bond is on the third one, so it doesn't matter how you number them. There's 6, so we know it's going to be hexene, and we know it's going to be 3-hexene because the double bond is on the 3. We also have to tell cis or trans because it's shown. So we would say, because the chains are on opposite sides, we would say trans 3-hexene. Now, alkenes and alkynes can have substituted groups off of them, but you follow the exact same rules. So remember the rules we learned for alkanes, those first ones, those are the foundation. Everything else you add to that, and then this, and then that. So there are lots of complex rules, but if you remember your foundation and you go through it step by step, you can get there. In this case, I'm going to leave out all those hydrogens, which means that you cannot tell me cis or trans, which is fine. I know that numbering either way will put the double bond at a 2, but we want the substituted groups closer to the 1 end. So we're going to say 1, 2, 3, 4, 5, 6, 7. So we know this will be heptane of some sort. And we have 2 substituted groups. They're both methyls. They're at 2 and 4. So 2, 4, dimethyl, to tell me that there are 2. And then we would say 2 and 5, hepta, because there are 7 in the chain, diene, because there are 2 double bonds. Remember, di tells us 2, and the ene tells us double bonds. We don't say diheptaene, we say heptadiene. Let's look at some alkynes. These have triple bonds but follow the exact same rules. For our first example, I'll show it in the condensed form first, so that you know how to tell the bonds are there. So you might look at this and say, I have no idea where the double or triple bond is. But if you look, these carbons don't have any hydrogens off of them. So they have 1 bond here. That means the other 3 bonds have to be here. So if there's just a C, and there's no parentheses showing there are substituted groups there, then it is a triple bond. If it was CH, CH in a row like that, then that would be a double bond. So we draw this. We don't have to draw all the hydrogens. We can visualize them. Those would be 3. Those would be 2. This one has no hydrogens off of it, so it has to have all the bonds there. 2. This only has 1 hydrogen, so it must have that methyl group on the side. Now we can see that we have a difference here. And the last one, the double bond, was going to be at 2 no matter what, so we named it so that the substituted group is closer. But in this group, we have to decide, do we want the substituted group at 3 or do we want the triple bond at 3? And in this case, the bond wins. So 1, 2, 3, 4, 5, 6, 7, 8. Though if you named it the other way, it wouldn't be technically correct, but if someone were to draw it, it would look the same. So we have 8 in a row, and because we have a triple bond, it is now octyne to tell me there's a triple bond with the YNE, and there is a methyl group off of 6. So we would say 6 methyl 3 octyne. Let's try just 2 more. Now you might look at this one and say, oh, it's drawn like this, I have to tell cis or trans. But because the triple bond is at the end, you can't. There is no cis or trans. So let's number. And that bond will be number 1, 2, 3, 4, 5, 6. So we know this is a hexyne. And we know specifically that it's going to be 1 hexyne. And all 3 of these are methyl groups. So what we would say is 2, 4, 4, the location of all of them, try to remind us that there's 3, methyl. One final example, because if I don't do it, I know somebody's going to ask about it. What if I have a triple bond and I have a double bond? In this case, instead of using "-ine" or "-ine", you'd say "-ine" at the end to let me know double, triple. And we want our numbers to be smaller. So we would say 1, 2, 3, 4, 5, 6, 7, 8. And this is a propyl group because it has 3. So we would say 4 propyl. And that's not changed. And then we have 2 special bonds. We have a double and a triple. And when you're naming and you're writing where they are located, list the double bond first. No matter which order they physically come in you always list the double bond first. So we'd say 1, 6, and it's oct because there's 8, oct, and 9. So this tells you a double bond at 1 and a triple bond at 6.